The position of an object attached to a spring is given by the function where t is time in seconds. In the first 4 seconds, how many times is the velocity of the object equal to 0? So notice that the given function is the position of an object, and we're being asked to use the velocity function, right? Which we don't have. So that means we need to first find the velocity function in order to answer this question regarding the specific times when the number of times at which the velocity is equal to 0. So let's find the velocity. So the velocity is going to be labeled as y prime of t, because that's precisely the derivative of the position function. So we have to take the derivative of each of these terms. Notice that there's chain rule involved, because first the outer derivative is going to be the cosine derivative, and then the inside will be the 5t derivative, right? And we know that the 1/6 is a constant, so that goes outside. So we know we're going to have a sine as the derivative of the cosine, but it's going to be negative sine, right? So make sure that you keep that in mind. So it's going to be negative 1/6 sine of 5t, and now you're going to use the chain rule. You're going to take the derivative of the inside, which is 5, right? Because derivative of the 5t is 5. All right, now the second term is going to be, so the derivative of the sine is cosine. That doesn't change the sign, so the negative remains. Negative 1/4 cosine of 5t, and then derivative of the inside, which is 5 as well, okay? So what we're getting, the result of which is going to be this. Y prime of t is equal to minus 5/6, right? Because we can bring the 5 here. So minus 5/6 sine of 5t minus, now 5 we can bring there as well. So minus 5/4 cosine of 5t. Right, so that will be the velocity function that we just found, that we derived from the position function. So now let's understand what's being asked. We have to find the number of times at which the velocity is equal to 0. Okay, so we have to set the velocity function to 0, right? So let's do that. So 0 is equal to minus 5/6 sine of 5t minus 5/4 cosine of 5t. Okay, so now that you set it to 0, keep in mind that the question doesn't ask you to find the t values that yield the function, the velocity function, to be 0. That's not what they're asking. They're asking how many times is it equal to 0. Okay? Now, in order to ask this question, what I would do, I would basically add one side. I would add 5/4 cosine of 5t to both sides in order to yield the following result. So, well, actually, let's add this one. So if I add this to both sides, look what happens as a result. So I'm going to add 5/6 sine of 5t to both sides. Okay, so if I do that, what I'm going to have is this. 5/6 sine of 5t is equal to minus 5/6 cosine of 5t. So all I did was I brought this term to the left side, and I made it positive, of course, because I had to add on both sides. So as a result, the left side is no longer 0. It is 5/6 sine of 5t is equal to minus 5/6 cosine of 5t. So again, we're not looking for the t values that make this equation true. We're looking at the number of instances at which this equation is true throughout the t value from 0 to 4, right? Because it says in the first 4 seconds. Okay, so that means from t is equal to 0 to t is equal to 4. Okay, so through the interval from 0 to 4 inclusive, we have to find how many times this equation is true, and that will answer the question. Okay, so let's understand what the graph looks like. Notice that the good news is that the period for these two functions will be the same. It will be 2 pi divided by this coefficient of t, 2 pi over 5 precisely. Okay, and why 2 pi? Because we know that the standard sine and cosine functions each have 2 pi as the period, right? So we have to use that 2 pi and divide by the coefficient of t to find the period. And luckily, the period for both of these guys is the same. So we can use the graph to understand what this is going to look like. So notice that, and don't worry about these coefficients. I mean, the negative and positive do matter, but the 5, 6 doesn't really matter. It doesn't really change the game. First, we have to see what the sign looks like. So we know the sign, since it has the positive coefficient, it looks like this. Okay, so this is one complete wave. And we can trace the vertical line connecting that terminal point at which the one wave is fully covered of the sign. Now the cosine, notice that it's a negated, right? It's a negated coefficient. Don't mind the 5/6, but it's negated. You know, usually the sign starts from the top, but here it's going to be, you know, it's going to be reflected through the t-axis because of that negative sign. So it's going to start from the bottom instead. Okay, and luckily these two numbers are the same. Well, in which this matters. They're the same, so that means the magnitude is the same. The amplitude is the same in this case. So that means the lowest point for the cosine will be the lowest point of the sine, right? So we can start here, and it will reach its peak right where the sine is equal to 0, right? Right at this point here, it's going to reach its peak, and then it's going to go down again, and it's going to be down here at that terminal point, again at the lowest point possible where the sine is as well, right? So here. Okay? Now, think about this. We're trying to find the number of times that this equation is true. So what we're getting at is the number of intersections between the sine and cosine, right? So as you can see, there are two such intersections in one complete wave for each of these functions. This one and that one. So there are two intersections per each wave for each of these functions, right? Two intersections. But we're talking about 4 seconds, right? We're talking about the interval from t is equal to 0 to t is equal to 4. And we don't know, and this period is what? It's 2 pi over 5 seconds, right? So one complete wave is 2 pi over 5 seconds. But 2 pi over 5 seconds is smaller than 4 seconds, right? So we have to find the number of intersections in the period from 0 to 4, because it's definitely going to be more than 2. So to find that out, first, let's understand that, once again, the period for both is 2 pi over 5. You divide by the coefficient of t. You divide 2 pi by the coefficient of t. In this case, the coefficients are the same. That's why the graphs look aligned very well. The full waves match, right, for each of these. So 2 pi over 5 is the period, and we can say that it's seconds, right, because that's the t value, essentially. 2 pi over 5 seconds. So let's understand how we interpret the number of waves. So we're going to take the entire time in seconds, and if you divide that by the period, which is also in seconds, seconds per wave, right? Because the period is seconds per wave, right? Make sure you understand that. Not just seconds, but seconds per wave, right? So in one wave, there's a certain number of seconds. That's the period. And the period is the same for these two functions. So if you divide time, which is just seconds, divided by the period, which is seconds per wave, look what happens. The wave is going to be the denominator of this denominator, right? And as a result, the seconds cancel out, and the wave comes up. So this is equal to the number of waves. So using this, we can successfully find the number of times, the number of intersections. So how do we do that? So first, we're going to take two intersections that we found per one wave. So two intersections per one wave, as we've noted already using the graph. So there are two intersections in one wave. And then the conversion factor, of course, is going to be what? We're going to take the full time, which is the period from t is equal to 0 to t is equal to 4. So 4 seconds. Divide that by the period, right? Using this formula. Period is 2 pi over 5 seconds per wave. So as a result, what you're talking about is this whole thing is waves, right? As we've noted. So this we can measure as waves. We can label this unit as waves safely. So 4 over 2 pi over 5 waves, okay? So as a result, look what happens. The waves cancel out as units, right? Because this waves goes in the numerator. And the only thing that is left is intersections. And that's exactly what's going to answer this question, okay? So as a result, your calculator, if you do this right, should give you 6.36 61977 24 intersections. Okay? So in the period from t is equal to 0 to t is equal to 4, the number of times the velocity is equal to 0 is 6.36 seconds. Now, which answer choice is the closest one to this result? You can't say 7 because that's not enough. You cannot round up, of course. You have to write down. There's no other choice, right? So the correct answer to this is 6. About 6 times the velocity of the object is equal to 0 during the first 4 seconds. Thank you so much for watching. I hope this was helpful. See you in the next video.